All right, hi class. Today we're going to look at the Simpson's diversity index and the homeworks. So if we look, we're going back to the same equation in which we can calculate diversity. And we're given this equation, which looks a little complex, but it's fairly doable. It's very doable if you just lay it out correctly. So D is the diversity index, and you'll get some sort of number, usually a decimal point, to a couple of places. And then if you look after that, we have this capital N times capital N minus 1. So the capital N, as it says down here, is the total number of organisms found in the area being studied. And then it's divided by, and this is the letter sigma, which means the sum. So this is the sum of now lowercase n times lowercase n minus 1. So the lowercase n is the number of individuals of a specific species. So we're going to quickly take a look at the practice problem, and then we're going to do one of the other ones together, and then you'll try the rest as homework. So our example here says we're looking at a lake. It contains 934 brown trout, 733 smallmouth bass, 34 catfish, 2,003 carp, 234 steelheads, and 32 northern pikes. So first, and this is exactly what you should do when you do your homework problems, you should draw out a data table. In the first column, this says fish, but you can just write species. So your species names will go along the side. Then the number of organisms of each species will be listed out. So brown trout was 934, the smallmouth bass was 733, the catfish is 34, the carp's 2003, the steelheads are 234, and the northern pike's 32. Then what we're going to look at, we're going to draw out the whole table. So they're leaving another room down here for the totals, and then they're leaving a column to calculate the lowercase n times lowercase n minus 1. So you want to draw that out as well. So you're giving yourself 3 columns, and the number of rows will depend on the number of species you have. So you're going to put all the different species, and then kind of plus 1 row for the total at the bottom. So here, all they did was they added up these numbers in the column. So they added up 934 plus 733 plus 34 plus 2003 plus 234 plus 32. So this should be equal to 934 plus 733 plus 34 plus 2003 plus, where am I? Plus 234 plus 32. So you can double check it on your calculator if you want, but that's what it should be equal to. I'm going to try and zoom in a little bit. Okay. Then our other column. So we're starting the calculation so that we have that sum for our denominator for the calculation for diversity for the Simpson index. So if you look, we're trying to calculate the lowercase n, which was the number of individuals of each species, times the number of individuals of each species minus 1. So to set it up, all you're doing is you're taking 934 times 934 minus 1. So of course, really we're just taking 934 times 933. So you don't need to have this, you don't need to do it on scratch paper. I just pull out your calculator. Okay, that's my phone. It's really bright. I'm sorry, but 934 times 933. Okay, and we should end up with this number. So we've got 871,422. So that's our number there. So we're doing the same thing as we move down the column. So you'll see this time we didn't add the minus 1. I mean, that should be simple enough mental math, so you don't need to write it out necessarily. So they just did 733, okay, times 732. Okay, calculated their number there. Then they did 33 times 34. Then they did 2003 times 2002. Then 234 times 233. Then 32 times 31. And they've got all of their calculations for each species of the lowercase n times lowercase n minus 1. So because in our denominator we're looking for the sum of all of these numbers, They're just making that calculation right here. So again, if we wanted to show our work, so this should be equal to 871,422 plus 536,556 plus 1122 plus 401,006 plus 54522 plus 992. Okay, so they're just adding all of these numbers together, so you can always double check it. So now once they add them together, they're saying that this is their final result. So they have 5,474,620. Okay, done. So now that they have that information, they already have their denominator. So all we need to figure out is what's in the numerator for this problem. So we have here, okay, again as a reminder, our D equals now capital N, which was the total number of individuals of all species, times capital N minus 1, divided by the sum of lowercase n times lowercase n minus 1. So looking at those numbers we just calculated in our third column here. So the capital N we already determined. So this is 3,970. So again, we need to do a small mathematical calculation. So we take 3,970 and then we're multiplying it by the 1 less than 3,970. So that's 3,969. So plug it into your calculator and this is what you get. So this time we've got 15,756,930. So we have now our numerator here, okay? So this is our numerator. Hopefully I'm using my math terms correctly. It's been, more than a decade probably since my last math class, but that's okay. And then we also had our denominator already up over here in the corner. So we've got both of them. So now we just plug them in. Okay, numerator, denominator, get your calculator, plug it in, and then we're going to use 2 decimal places, okay? So we'll round to the nearest hundredth. So whatever you get here, we'll round, okay, to the nearest hundredth. So this is 2.88 for our diversity index. So really 2.88, like what the heck does that really even mean? And the reality of the situation is if we're just looking at one number, it doesn't mean a whole lot. So this is better used as a comparison between 2 different ecosystems. So we're going to choose one more just as an example and we're going to draw it out. So this actually says to do the problems in your notebook. So I would grab a notebook. It would be easier to do on lined paper, but I actually don't have any lined paper right here with me, so that's okay. And I'm just going to look at the first one on the back, and there are some little analysis questions. So the first one says, we're supposed to calculate an area of the Black Forest in Germany that contains 134 pitch pines, 24 Douglas firs, and 53 red pines. So we're drawing out our data table first. I'm going to leave mine open because I don't know how big I'm going to write. So I'm just say, okay, so I have my species. They're all trees, but I'm just going to say species. And then in our next column, we're getting our number, lowercase n of each. And then I'm going to calculate my lowercase n times lowercase n minus 1. All right. Giving myself plenty of room there. So I think I just had 1, 2, 3, and then I wanted my total. Okay, and then I'll close it off. Hopefully that's the correct number. Okay, good enough. It doesn't have to be perfect. Okay, use your notebook, it'll be easier. So we had 134 pitch pines. Then we had 24 Douglas firs. Then we have 53 red pines. Okay, perfect. So now we're just doing those calculations. So we have 134 times 133. Then we've got 24 times 23. Then 53 times 52. So remember, we're just taking the 1 off of the lowercase n number, okay? Done. Then at the bottom, we wanted our total. So I'm just going to make my capital N. Hopefully you can tell the difference here. Okay. So I need to do some calculations, so I'm not doing this all in my head. So I'm just going to grab my calculator, which you are free to do. Maybe first I want to find my 134. Oh, wait a minute. I'm going to see if I can change my screen brightness so that it's not just glowing in the video. Okay, there we go. So 134 plus 24 plus 53. So that's going to give me 211. Okay. Then on the other side, I still have to do this multiplication right here. So I'm going to delete this 130. Did I do 132 or 134? Now I'm sorry, I'm just questioning myself if I entered 132 or 34. So I was talking and worried about the screen. Okay, I did. Double checked it. Perfect. So now I'm going to multiply 134 times 133, and I get 17,822. Okay. 24 times 23, so 552. Then 53 times 52. And that's 2756. Okay. So now I'm adding all of those together. So I'll start with the one I have already on this screen. And then, oh no. Oh, it went dark. Oh, shoot. Let's see. I'm not sure why that happened. It says exposure. Okay, I'm going to pause for just a